Okay, this is lecture 21 on dividing polynomials. The first thing we'll do is just a monomial divided by a monomial. That's just one term divided by one term. And then we'll do polynomial divided by monomial. And then we'll do the last one in the new video. So if we have a monomial divided by a monomial, first of all, you can tell how many terms there are by looking at how many plus and minus signs there are dividing the terms. So here we don't have any plus and minus signs, so even though it's kind of long and gross looking, it's still just one term over one term. So let's simplify the top first. 9 times 4 would be 36. U squared times u cubed would give me u to the fifth. And then v times v cubed, I have 1v and 3v's, so altogether I have 4v's. Next, I'll look at the number parts. Look at 36 divided by 12. 36 divided by 12 is just 3. U to the fifth divided by u to the fifth. There's a lot of ways of thinking about that. All of them are right. Well, all the right ones are right. So u to the fifth divided by u to the fifth. You could say that the u to the fifths cancel. Or you could say u to the 5 minus 5, which is u to the 0, which is 1. Any way you look at it, the u's go away. And then 4v's on top, 2v's on the bottom, leave me with 2v's on top. So I just have 3 from the 36 over 12. I don't have any u's, and v squared. So this is really just a lecture 18 problem. All we're doing is using our rules of exponents. Let's look at one that's a little more involved. But first of all, I want you to see if you can find the mistake in one of these equations. If you're having a hard time seeing it, let's see which one must have the mistake. Is 7/2 the same as 3/2? Yeah, it is. So hopefully the first one's right. Is 7/2 the same as 4? No. So let's look and see if we can find the mistake in this second equation. 7 is the same as 6 plus 1. So that should be okay. Can I cancel? Now I have 2 going into 6. Can I cancel that 2 out of the 6? No, that's the mistake. I cannot cancel unless I cancel from every single term. So I could cancel that 2 into 6 as long as I was taking the 2 into 1 as well. So the rule that we will use is if I have a plus or minus b over c, then I'll have a over c plus b over c. In other words, if I have multiple terms in the numerator and one term in the denominator, then I just split my big fraction into mini fractions. So let's see how that applies. 4b squared plus 16b minus 12. I have multiple terms. In fact, I have 3 terms in the numerator and 1 term in the denominator. So I'll split it into many fractions. I'll take 4b squared over 4, 16b over 4, and 12 over 4. I would not just cancel the 4 from the 4b squared and the 4 in the bottom. I can only cancel if I do it from every term. Now, the 4b squared over 4, I can cancel those 4's because there's only one term in the top and one term in the bottom. So those cancel and just leave me with b squared. In the second term, I'll get 4b, and then the 12 over 4 would give me 3. So that is how we will do if we have a polynomial, if we have many terms, divided by one term. If you only have one term in the bottom, you'll split it into many fractions. And so we'll do those just like mono over mono. We'll just use our exponent rules. Okay, these 3 examples I want you to do on your own, and we will solve those in the next video.